Okay, hello everyone. Hello and welcome to this webinar that is also a masterclass from OPIT. The title of the masterclass is The Future of Industrial Innovation, so leveraging AI, digital twin, and IoT to transform industries. A very warm welcome. My name is Greta. I'm head of marketing and admissions, and I'm very happy to be tonight here with Professor Andrea Gozzi. Hello, Andrea.
Hello.
Andrea is head of strategy at Siemens and is also a professor at OPIT, and he teaches digital business. So I will give you a very brief introduction about OPIT, and then I will just leave the floor to Andrea. And at the end, if we still have time, I'll just go and give you an overview about our programs, about the admission process, and answer any questions. So at the end of the masterclass of Andrea, if you have questions about his speech, please do that using the Q&A button that you can see here in Zoom. So a few words about OPIT. Our mission, we are an institution that actually offers bachelor and master of science degrees in technology. So our mission is really to unlock progress and employment, offering a top quality education that is at the same time so top quality, but also affordable. And the specific field is technology. So some key traits about our organization. First of all, we are recognized at the European level. So we offer degrees that at the European level are recognized within the EQF system, but also outside Europe, so in America, Canada, and so on. Our programs are all online. They're fully online, very flexible. But at the same time, as you can see in this chart, the support is always available. So you will attend lessons. You will have the opportunity to talk to professors like Andrea, to have tutors every day of the week, and many other point of contacts. We focus on technology, so computer science, digital business, AI, data science, cybersecurity, because this is what we believe is the future. This is our expertise, and that's what we think everybody should learn as well in this very specific period of time where technology is kind of changing the way we do business as well. Talking about business, we are career aligned. That means that our degrees are very modern. They offer what you should know today about technology and how to implement it in the business. Our professors as well, like Andrea, they come from the business field, and that means that you can have a full exposure about what should be technology applied to business. And finally, we believe to be inclusive with the online opportunities anybody can connect and affordable at the same time. So just as I mentioned, the professors, these are one of our key strengths. Our professors, as I said, they come from both academia and the business. You can find more details about our faculty on our website. This is just a snapshot. So we have professors coming from, of course, the academia, like our rector, Professor Profumo, has been also Minister of Education in Italy, but we have faculty coming from companies like Amazon, Microsoft, Morgan Stanley, and so on and so forth. And Andrea himself is head of strategy in Siemens. So without any further ado, I'll just leave the floor to him for his masterclass.
Thank you. Welcome, everybody. Can you hear me?
Yes.
Okay.
Yes.
I'm Andrea Gozzi, and I'm a teacher at OPIT. I teach digital business platform, which is a topic putting together technology and business and new business models. Today, I'm giving a class, a lesson about industry, because this is my field of application for all my career. I started my career at Siemens 20 years ago after my PhD in computer engineering. And within Siemens, I changed different roles. I started with a technical role in research and development, and currently I'm leading the digital strategy for the company in the Italian market. I am giving you a taste of what is industry nowadays. Don't know who of you knows the industry sector. sometimes I meet people with little knowledge of industry, and the perception is of industry is something old style. Especially with the new generation, I met a lot of young people collaborating with universities, and they expect that innovative jobs and technologies are for tech companies only, and digital native companies like Amazon, like Google. And they think industry is something related to iron and steam. So today I have a challenge to change your opinion about the industry, if this is your opinion. And I will drive you in learning what are the emerging technologies in the industry and the future technology of industries, and the reason why this is important, and why this could be a very interesting job opportunity landscape for all of you, especially after training with the digital skills, STEM skills, technology like OPIT classes are providing. Because I assume not all of you knows industry, I'll start my presentation with a video showing an example of an industry. This video is taken from Rolls-Royce in the UK, and this is a company I worked for years ago. In this factory, the engine for the large Airbus aircraft, the new A350 aircraft, is manufactured and assembled. And you can have a taste of what assembling an engine of an aircraft, a big engine of an aircraft, means. The factory layout is located in Derby, in the United Kingdom. The assembly of the extra wide body aircraft. Very high specialized technology. This is considered one of the most complex manufactured pieces in the world. Due to its complexity in terms of number of components, limited spaces, and complexity of wiring and piping. And of course, the final quality of an aircraft engine is not a compromise. Nobody wants to travel with an aircraft with some technical issues, especially in the engine. Most of the parts, of the mechanical parts, are manufactured within the company using another part of the process by metal cutting, special machines. Other parts are supplied from external providers, international. For example, the big part at the bottom of the engine in this moment is manufactured in Spain by a subsidiary company of Rolls-Royce. There we go. The engine is almost completed. See this in accelerated mode, but the entire process requires weeks. This is testing facility. We had the occasion to stay in. It's like a small cockpit of an aircraft to switch the engine on and to test a lot of parameters. This is the final packaging in order to ship the engine to the customer somewhere worldwide. So if it is new one, most likely in Toulouse, where the aircraft is assembled. Okay. So what are the challenges today in manufacturing, creating things? For sure, at the moment, one of the critical characteristics of the market is the geopolitical instability. I'm sure you listen about the tariffs. This is the news of the moment. And this is very disruptive for decision makers because they don't know where and how and what invest for. A second challenge for a manufacturer is the labor shortage. Manufacturers have a lot of difficulties in finding skilled people. This is due to changing demographics and also changing society. In the old days, people used to learn their job by learning on the field by staying working close to a senior person and working together, a junior person with a senior person, and the transfer of know-how occurred because of this job synergy. But now society is different. People travel a lot. People want to change their life, their professional life, changing job, changing employer. So companies cannot leverage any longer on long career of people in the same position. And this causes that people need to be trained and skilled quickly to become effective on their job frequently. There is a big pressure about sustainability. Manufacturers need to manufacture items that are more sustainable, green, and to manufacture them in a more sustainable way. So manufacturing processes have to be sustainable. There are also big opportunities for the industry, and those opportunities come from the new technologies. At the moment, the most important technologies for industries are artificial intelligence, digital twins. I'm going to explain clearly what a digital twin means. Industrial Internet of Things, which means possibility to have objects connected to internet in order to deliver data and to be controlled remotely, and robotics. I want to show you a second video of
in a world where the complexity of aerospace architecture and systems continuously increases, SimCenter answers engineering challenges with its dynamic and integrated model-based engineering approach. From the component level to the entire integrated aircraft, SimCenter supports your electric and hybrid electric system design using agile product development and engineering.
Center is a product of Siemens for this engineering task.
SimCenter helps you reduce your overall development costs by securing certification while you design. It provides essential proof of compliance data using both virtual and physical testing for the mission-critical certification process. SimCenter can help reduce risks associated with developing hydrogen fuel cells or hydrogen-fueled gas turbine. It addresses challenges related to storage, distribution, and energy conversion. By improving aerodynamics and structural performance, you can further reduce an aircraft's weight to improve overall efficiency and sustainability without compromising safety.
You noticed how many data, simulated data, engineer can have just using software, without any prototype, without using the wind tunnel to test the effectiveness of the aerodynamics. What is funny, and I put in the presentation, is that engineer people using this tool also have crazy ideas, like evaluating the impact of the famous DeLorean car from Back to the Future movie. I think people of my age know this movie for sure, with Michael J. Fox performance. And this is an example of how people enjoy doing their job by having this kind of powerful tool in basically predicting everything about the technology and about physics or mechanic. It's like somehow to be able to predict the future of how an item will behave in the reality. And one more.
The pace of digitalization is unprecedented.
How our software in the factories can help is
the pace of digitalization is unprecedented, and it's completely transforming our world, harnessing new technologies across the landscape of industry to fundamentally change the way we live. The factory of the future will be created with intelligent connected machines that are both adaptable and extendable, and can provide strategic operational insights to improve efficiency. It's all enabled by digital threads that turn silo data into connected disciplines and processes. These threads form the neural network of a digital twin, a virtual entity which mirrors the physical world, turning data into insight to continuously design, build, and optimize throughout the product and production lifecycle. This approach gives engineers new opportunities to create breakthrough innovation, leveraging virtual simulation and field intelligence to deliver customization and accelerate time to commission. Adaptable production lines reduce setups and cycle times, and a digital manufacturing process optimizes for quality and shop floor throughput. During and after field commissioning, the physical machine feeds data back to the digital twin, so teams can predict problems, proactively service machines, and improve the next generation of equipment. Siemens can help you achieve.
I'm not giving any commercial of the products. I use this example to show you what is a digital twin and what software can do. In more detail, the way of manufacturing is changing from an automation approach to what we call an adaptation approach. Automation means that machines can do things without receiving manual commands and without human contribution. So automatic machine is something you saw in the videos. But today, manufacturers are looking for adaptive machines, which means machines that can take decision and machines that can change their behavior in order to be able to produce something that was not known at the time that the machine was designed and constructed. And this is really challenging for engineers because nowadays all the machines are designed after the design of the product. So the typical process in manufacturing is product engineering, which means the phase during which people design a new product, like for example, the new aircraft or the new aircraft engine. Then there is the phase of process engineering, which means deciding how to produce the product by deciding on the usage of machines, usage of materials, usage of tools. And then there is the real production execution with the machines specifically constructed or specifically tuned to realize the well-defined product. The goal of the new manufacturing is to have machines that are able to produce a new product without changing the machine setup and without the necessity to reprogram or retune the machines. Now I will show you what are the steps toward this goal and what are the challenges in this goal. Let's start with the AI. AI is giving a lot of promise to the industry because companies already expect to reduce the cost of maintenance in machines by halving the cost of machines, and even better, the time a machine is idle or not working because of maintenance. And also the AI can improve the losses of performances, so helping to use the plant at maximum capacity. And for an investor, the plant, the machines are capital intensive, which means that in order to return from the investment in new machines, in new plants, in new factories, the usage of machine has to be as high as possible. But the new frontier is the generative AI in engineering, which means using AI to simplify or to speed up the role of the engineering people, defining new product characteristics or new process, how to produce the product. I'll show you a video about AI application in one of our factories. In this case, the production is regarding electronics. So we are looking at the video of machines assembling electronic components like the PC motherboards. In this case, robotics is applied.
Die Zukunft in Sachen KI wird
The future of AI is becoming very exciting. We're uncovering new possibilities almost on a daily basis that we then implement in our production as soon as possible, so we can make our products better and more efficient in production.
ein typisches Beispiel für
A typical example of how the electronics factory Erlangen uses AI is for picking unsorted pieces from crates. Normally, a robot can't just pick and strategically place unsorted pieces because it has no understanding of its environment. AI gives the robot the ability to carry out this process.
diesen Prozess umsetzen kann. Ein Roboter lernt
A robot learns to identify and pick pieces through demonstration.
Demonstration oder Vormachen.
What's special about our Siemens solution is that we use the digital twin of the product itself to generate virtual data that the robot can then use as visual material.
Dienen können.
One of the specific benefits of this type of solution is a massive reduction in training effort. The second benefit is that compared to traditional automation systems, we can use simpler hardware that is also much more affordable thanks to the much more intelligent software.
Es einsetzen. Die
The
Einsparung
savings compared to a traditional system that operates without AI are between 90 and 95%.
Ein weiteres Beispiel
Another example of how the electronics factory Erlangen uses AI is in the tactile placement of electronic components.
Bauteilen. Die Teile
The pieces are extremely sensitive. The tiny pins that protrude on the bottom often have a diameter of only a few tenths of a millimeter, which means that simply aiming at an endpoint often fails. A human has the dexterity to do this, and we simulate this dexterity in the automation system using
der
AI.
Automatisierung nach. Solche
This type of automation solution also has a positive effect on quality, for example, because the robot naturally works on the basis of a fixed part list, which means it can never forget a piece or insert one piece too many.
aus der Automatisierungslösungen
And because we can also track feedback from the automation solution, we can boost our process quality over time based on data.
Siemens spielt
In the field of industrial AI, Siemens plays a very special role because Siemens already covers several domains that are central to this area. We have the connectivity technologies to channel and process data from processes, and for example, to make this data available to learning processes. We have the technologies for the digital twin, so that AI-generated solutions, new strategies, etc., can be simulated virtually before we use them in reality. At the same time, we also have the control technology necessary for the industry-ready deployment of these AI algorithms, for example, on an edge device.
Siemens Accelerator.
Okay. I will focus on the interesting part. Before moving to the next use case of applied artificial intelligence, I want to explain a little more about what we saw in the last video. It could be strange, but currently robots are not intelligent. Industrial robots are in place. Industrial robots generally are less intelligent than our vacuum cleaner in our apartment, like the Roomba, for example. In the sense that the robots don't take decisions. There are many robots in the industry, but they are very limited in their actions about the movement they can do, and they do what they received as a program. And what was explained in the video is that now, because of AI solutions, robots can be more adaptive to different working environment. And pick and place picking is a difficult task for a robot, because picking an item in a bin means the robot can understand the position of the item and clamping it in the proper way. And items can be very different, and especially in a factory that manage a lot of different items, visual recognition of the item in the right position can become a difficult task. And what is interesting in this video, if you notice, that training of the robot, of the machine vision of the robot, is done with artificial data. And we will see later in another video, there is the possibility to generate synthesized data, so false data, but realistic, like images, in order to train the machine vision. And this software that generates images using AI prepare all the possible images with different type of lights, different type of contrast, with some dust on the item, in order to train the robot to recognize the item in any condition. And I found this is very, very smart and astonishing. Now I show you another use case, another video with another product using AI with the data collected from Internet of Things. You listen about the importance of having different technologies working together. AI, artificial intelligence, digital twin, Internet of Things, all the technologies have to work together in order to give a real valuable solution for the industry. And now I show you an example of AI applied to connected data. This is a software, I'm explaining this is with our video. This is the software connecting the data from the same machines you saw in the previous video, the surface mounting technology machines. It is an IoT, talking with the machines, and within this software, there is a co-pilot, and the co-pilot was instructed with maintenance data and technical support data. This is the technology. Data collecting, different type of data, converging in a software and then going to the cloud. And if there is a problem, for example, with the nozzle, the system suggests promptly the solution and it provides the instruction how to maintain, in this case, the nozzle, which is a periodic cleaning operation. And with the software, the operators in the factory can track what they are doing. And the software is also interacting with the execution system, which is a software organizing production, to check how much these activities for maintenance will impact on the production. And this is very important because in this way, the production managers can report promptly to other departments like logistics about any possible production disruption. I think now you have a better idea of what digital twin is. It's basically a virtual control room that allows to simulate production before executed or before preparing for production, optimize operation, and accelerate innovation by testing and try different configuration with a trial and error approach, which of course will not be possible with the real item. Imagine what trial and error would mean in a factory. We are talking physical things, and any mistake could be a big problem in terms of business continuity, which means risk to block the production, risk to damage the equipment, or even worse, safety risk. I want to show you one of the most advanced example of digital twin. This is a well-known case by Siemens and NVIDIA. Look at carefully, because then I will spoil you some things that will be, I think, entertaining.
Siemens and NVIDIA are partnering to advance industrial digital twins in the metaverse, opening a new era of automation for manufacturing. In this demonstration, we see how the expanded partnership will help manufacturers respond to customer demands, reduce downtime, and adapt to supply chain uncertainty while achieving sustainability and production targets.
I'm sorry.
Siemens and NVIDIA are partnering to twins in the metaverse of the expanded partnership to supply chain.
Just to say this. Maybe it's clear for you, but it was not for me. So I mentioned that this is not a real plant. This is a video game. This is artificial intelligence created, which in my opinion is astonishing. It's a realization of NVIDIA Omniverse, this software, using input from another software by Siemens, which is called Plant Simulation. It's a software for designing, engineering new plants. Keep watching and you will see. I'm sorry, I'm not good with this.
The partnership will help manufacturers respond to customer demands, reduce downtime, and adapt to supply chain uncertainty while achieving sustainability and production targets. By connecting NVIDIA Omniverse and the Siemens Accelerator ecosystem end-to-end, we will expand the use of digital twin technology to bring a new level of speed and efficiency to solve design, production, and operational challenges. Siemens Accelerator offers the industry's most comprehensive digital twin and includes best-in-class software for digital manufacturing, collaboration, design, and industrial operations. Omniverse, based on the open standard of USD, Universal Scene Description, connects a wide range of software tools and users with AI, physically accurate visualization, realistic physics, and ray-traced RTX rendering. NVIDIA Omniverse is a large-scale, full-fidelity virtual world engine and ideal for industrial metaverse. The connected platforms running on GPU-accelerated systems from edge to cloud unlock amazing superpowers, from factory planning to autonomous robots and beyond. Uniting the worlds of information technology and operational technology, the Siemens Accelerator platform uses edge-enabled devices to collect real-time IoT data connected to the digital twin. When problems occur, engineering, manufacturing, and logistics teams can immerse into the live digital twin to root cause the problem and develop a solution. New solutions can be tested and validated using the digital twin across thousands of scenarios and edge cases. eliminating the need for physical prototypes, reducing critical downtime, and increasing manufacturing agility. Siemens Accelerator and Omniverse train robot perception AI models on physically accurate synthetic data generated from the digital twin, accelerating both initial training and retraining in the event of production changes. In live digital twins, customers can train robots to perform tasks before deploying the AI models into the physical robot. Omniverse can even be used to train fleets of robots working in harmony. Industrial automation is being supercharged with AI. Inside a digital twin, customers can design environments that allow humans and robots to collaborate safely and efficiently. Together, NVIDIA Omniverse and Siemens Accelerator are bringing open collaboration to industrial automation, enabling full fidelity live digital twins to drive a new level of speed and agility in the era of software and AI-driven digital transformation.
Okay. Why it's so important to have so realistic simulations, the digital twin? Because digital twin will be used for any related activities to manufacturing, which is not the real manufacturing, which means validating, testing, training, sales. I know companies using the digital twin in order to provide the customer the proposal, the offering of the new plant. Instead of defining the requirements of the plant in hundreds of papers, sheets, they provide a digital twin, which is, of course, clearer, more realistic, more accurate, and also more enjoyable to read, to watch, and to understand. We reach this level of adaptive manufacturing by implementing the so-called software-defined automation, which means that the factory is not bundled by hardware and cables or connectors, but as much as possible, every decision is taken in software application, and those software applications are as much as flexible as possible in order to be changed, adapted, updated every time this is necessary. Generally, this is reached by using centralized intelligence delivered by cloud-managed architectures and with the capability to deliver changes to the machines by edge technologies. So we strongly use cloud technologies and edge technologies. So we are able to reconfigure a machine or update a machine in a similar way as we update our Android device or iOS device. One of the most advanced technology for industries is robotics, and especially robotics for movement of materials, the so-called automatic guided vehicle. Because they are mobile, they work in the factory without any wired connections. They are AI-driven, and they are really integrated in the full factory because they usually perform tasks between the manufacturing area, the real assembly or machining area, and the logistics departments, the warehouse or shipping area. You can imagine those robots similar to the Roomba vacuum machine. There are a lot of similarities. There are also devices, moving devices with an arm, so with the capability to handle items and working together. Those robots are used to move single packages or to move pallets or racks full of items. For example, Amazon is using robots in many sorting facilities. And if you have the possibility, I suggest to pay a visit. In many countries, Amazon allows visit to people. there is a website called Amazon Tour, and I really encourage you to try to book a visit.
Welcome to the Karlsruhe manufacturing plant, a site that manufactures over 24,000 different products. And some of them will change the future of industry. Industrial 5G will improve efficiency in multiple industries. And what's most exciting is that we don't just manufacture 5G equipment like our 5G routers here, we also actually use this pioneering technology ourselves. Come on, let me show you what 5G technology can do. This is Wiki. It's one of our AGVs in the factory that transports production parts. Wiki uses our 5G network in order to transfer from A to B and to communicate.
This little robot transports production components to the machines which process them further. He is part of our intralogistics system. Wiki is equipped with one of our industrial 5G routers that allows him to communicate within the private 5G network. The router receives a signal from the radio unit at the ceiling and tells the robot what to do next or which task to fulfill. Here in Karlsruhe, we use a private 5G frequency band so that nobody can interfere our processes and our data stay in our hand. 5G is perfectly suited for Industry 4.0.
Okay. In this video, you see two important topics: the AGV, the autonomous robot, but also the video introduced another technology, important technology for industry. It's the connectivity, especially the wireless connectivity. In this case, the colleagues talked about 5G, or better say, industrial 5G. I'm sure you are familiar with 5G because most of the mobile companies promoted it as an enhancement of mobile phones. And I think most of the capabilities and the value of 5G is still to come. Speed and download bandwidth is just one of the advantages. Other advantages of 5G is the possibility to create a private network, very safe network. And as the video said, if the mobile connectivity is used to control a machine or a robot, it has to be reliable and safe and secure. And here you open another topic, the industrial cybersecurity. Now, machines are full of software, which means they are also exposed to cybersecurity attacks. And a cybersecurity attack in the industry could be a disaster because of equipment damage or even worse, safety of people compromised. We applied some few basic rules. First of all, a product has to be secure by design, or security has to be embedded by design. We consider the converging of information technology and operation technology security. Operation technology means data that moves item, in few words, to make it simple. Imagine the impact of the different impacts of a cybersecurity issue, of a network controlling machines, equipment, or a network controlling just data, like financial data. Of course, also financial data are important because the risk is to lose a lot of money or to have a business continuity issue, like, for example, preventing a bank to operate, which is not good, of course, for the business of the bank, but there are no risks for the safety of people. An attack in operational technology could mean a damage of the equipment itself and a damage of an equipment. Imagine, for example, a robot that does not stop in front of person. It could be really dangerous. Also, cybersecurity is achieved by real-time monitoring of the communication. So the network of a sensible infrastructure is monitored always in real time in order to detect anomalous data transfer, anomalous access, and whatever could be a cybersecurity issue. Last but not least, in the industry, we applied the so-called zero trust architecture, which means any device into the network is considered untrusted. And this is a principle. None of the items could be considered riskless with respect to the others. Let's move to the conclusion of this class. All these changes in technologies also brings new business models and a new way of doing business. In few words, companies are moving from a product-based business to an outcome-based service business. Especially in machinery or in plants, companies selling machines, selling parts of plants, robots, traditionally make business by selling machine once and being paid for the machine transaction. In the new business model, machine manufacturer offer the customer a contract based on the output produced by the machine. So it's a pay-per-use, or even better, a pay-per-performance contract, which implies a lot of different way of revenue recognition, investment, capitalization. There are new business platforms where companies make business for industry. And this is my also class at OPIT. I teach digital business platforms. And because of my role, I'm very active on the business platform from Siemens, which is called Accelerator. I think you listened a few times in the videos. And this is exactly the platform led by Siemens to create a digital business with providers and consumer of innovative digital automation. And last but not least, the business in the industry is becoming more and more data-driven. And what we already experience in other businesses like finance, insurance, health, it's arriving in the industry. And this is important for you, student at OPIT, because industry will be a very interesting landing point for your career, for your professional. We will have a lot of demand for people trained on technology and scientific subjects. Of course, industry needs people. We are foresighting an industry where AI is collaborating with people, not substituting people. Most likely in the industry, AI has less chance to replace humans. This is a good sign of a positive and responsible place where to apply the AI. We see an important trend of IT and OT management. And this is again very important for job careers because many information technology jobs now need to be extended to the industry. And we see more and more people with computer programming background, computer network background, joining companies to work into the factory, not into the office. And of course, capability to manage data. I want to finish with the last example, last use case. Coming from China, this is one of our factories using virtual reality and augmented reality for services.
咦，那不是钟哥吗？他在干什么？钟哥，你又鼓捣出什么新东西？
你可能在游戏环境当中接触过 VR， 但是 VR 在我们的工业领域当中也发挥着巨大的作用，比如虚拟培训。我们现在可以对贴片头的维保工作完全在虚拟环境当中进行相关的培训。通过虚拟培训的话，我们可以极大的节约我们传统培训当中占用宝贵的生产时间，同时我们的员工也可以极快的在真实的环境当中去上手，进行相关的操作。
我可以试试吗？
当然，来。
virtual reality used for training of customer service staff. Also, we applied virtual reality to train people for safety, like safety procedures.
喂，设备故障，什么设备啊？产线设备出问题了，我需要指导一下。
那你现在要过去吗？
不用这么麻烦，可以远程处理。
This is an example of augmented reality to support the customer in order to solve a technical issue. We use a software called SiteCall, virtual reality, augmented reality software for collaboration. Look at this case. The customer is transmitting the video of the equipment, and the expert people remotely.
现在这两种技术已经被我们引入到了生产制造环节。我们使用 VR 技术对我们的员工。
Here, this is the final result. Then you can have the full videos in the presentation, and all the videos are available online. There are many other videos you are interested in looking at factories and innovation in factories. There is a lot to learn by watching those videos, in my opinion. Let's complete with final reflections, what we discussed today. For directions we give to our market, to customers, to industrial entrepreneurs, which are also important for you, because this is where companies will invest in the future, which means where we can also have new professions or improve our career. Investment will be in cybersecurity. Investment will be in creating adaptive factories. And adaptive factories means using artificial intelligence and using data. Monetize new business models, and which means we will seek a lot of competencies in a mix of business and technology. And last but not least, empower talent. So also capability to teach and capability to learn continuously is important. And I strongly agree with the OPIT philosophy. Learning is a recurrent step. So we learn during our phase of the career. Then we go to exploit our learn capabilities, but then we have to learn again to keep up to date with the new technology, because the world is evolving quickly, and in one life we will see a lot of technical disruption. Thank you for your attention. I hope you enjoyed this talk and the videos. I'm available for questions, for comments.
Thank you so much, Andrea. That was very interesting, and especially because maybe people don't realize how important it is nowadays for engineers as well to use these technologies more broadly. And that's why also we teach these things as well at OPIT. But in general, you never finish to learn, because I suppose that you are learning by doing yourself, coming from a long-standing experience. Well, I had a question, since you mentioned this technology will not replace, but will just kind of support new people to get a job. So how quickly do we have to adapt to the advancement of technology? What do people need to do once they start a job and this technology comes along and changes completely the way of doing business?
Yes, but we in the industry, we think this technology will not replace people. The replacement of people in the industry already occurred years ago.
Okay, with the other revolution.
With the other revolution, correct, exactly. The new technologies requires adapting in terms more on the side of business than on side of technology, I would say.
Okay.
At the moment, the industry is struggling more on the sales side, on the business side, on the legal term side than on technology. Technology is going faster than other subjects. Young people is very comfortable with the new technologies. what I suggest is not focus on a single product, on a single technology. You saw many examples today of software. I use software from Siemens because it's easier for me to fetch a Siemens material, but you find and find a lot of other similar softwares from other brands. And I suggest not to focus on a special tool, but focus on a mindset. So be able to have a mindset to work in a certain way, then you can learn the tool. We will learn the tool afterward.
But you just mentioned that technology will, like, in a way, the industry will not be affected, but because it's already embraced technology, but business will be. So I suppose people with a technical background need as well the digital business in order to explain what happens to the customers. Or,
Correct. I expect exactly. I expect that also the roles in the job that traditionally did not require a deep technology know-how will become a role with the necessity of a deep technology background. Especially, for example, some sales jobs. Sales, in the old days, sales was most a matter of soft skills. Imagine sales, organizing, selling events, negotiating the price. Society has changed. Many important shops nowadays do not negotiate. Oh, I think young people is not able to negotiate. I used to negotiate when I was a kid and I was buying some things I wanted. I was running little money. I was asking for a discount. I like this radio. How much is it? Oh, can I have a small discount? I don't have enough money. And the shopkeeper used to say, yeah, I can give you a small discount. Or today, this is old-fashioned. Nobody asks for a discount. You just buy on Amazon. You don't ask a discount.
It is true.
This has happened also in B2B. Also, transactions occurs on the digital sales. What does it mean? It means that the salesperson is not a negotiator, is not a people of relation, a person of relation, is a good technical guy.
So it has to show the different kind of facilities and what the product is about, how to solve the issues. Is mostly, which is the best way actually of selling in a way. It just I give you the proposal and it's for you. If it is for you, then yes, you're right. So that's what I meant. So sales people need to acquire the technical skills, and technical people need to acquire the kind of way of doing business and selling as well.
Yes. Yes. Correct. Yes.
Okay.
Absolutely. We are we see in the industry at the moment the most interesting profiles are the complete profile. Not MC. Not excelling in any specific task. So, for example, the very top talent in software programming is not today the most interesting profile for job. A good software programmer with some communication skills, with the ability to do some management of others, that's fantastic.
Okay, that's very good to know as well. Thank you so much, Andrea. That was very insightful. And as I mentioned before, this will be is recorded. It will be available on YouTube. And so if people have questions, can also reach out to you on LinkedIn because you're on LinkedIn as well. I know it's very kind to reply to our students.